Astronomers from MIT have called the radio signal weird and persistent. It seems to have come from the furthest parts of space. Scientists think the pulsing radio waves come from a faraway galaxy, but they can't say which one. There's a clear periodic pattern of radio bursts happening every 0.2 seconds, and this pattern has been compared to the steady rhythm of a human heartbeat. A rapid radio burst describes a signal that lasts for just milliseconds due to the short duration of the radio waves it emits. To this day, we still don't know what sets off these explosions, and 100 years ago, we had no clue either. Nikola Tesla's work on radios and remote controls made it possible for modern spacecraft to be controlled from billions of miles away. In his Colorado Springs lab in the year 1899, he managed to pick up radio signals from outer space. Tesla was the first scientist to harness the ionosphere for scientific purposes. For radio waves to go into space, they must first travel through the ionosphere, an ion-rich layer of the atmosphere. A radio signal from Nikola Tesla more than 100 years ago was delivered to Mars, so he spent the first part of his life developing communication methods across planets. Tesla started looking into the effects of high-frequency electricity and groundbreaking phenomena in his Colorado Springs laboratory in 1899. His sensitive lab equipment allowed him to pick up and record cosmic radio waves. He said he'd picked up radio signals from a planet other than Earth. They didn't believe him, since scientists knew nothing about intergalactic radio signals a century ago. But there are several strange sounds picked up by NASA that remain an incredible mystery. There's still the faint hiss of the Big Bang's explosion, and a scientist has it all saved on his phone. In 1964, Robert Wilson and Arno Penzias discovered the Big Bang's leftover radiation by coincidence. After receiving a contract from Bell Laboratories in New Jersey, they built the now famous Horn antenna to receive radio signals from distant galaxy clusters and supernova remnants. But no matter where they put it, the thermometer always read around 3.5 Kelvin higher than it should have. We now know that radio waves, leftovers from the first photons produced after the Big Bang, were responsible for its formation. Wilson has a recording of the waves on his phone. According to our understanding, this was produced by the primordial photons released immediately after the Big Bang and still circulating across space today in the form of radio waves. NASA scientists are trying to discover what's wrong with the Voyager 1 spacecraft. Possibly, this spaceship is broadcasting strange information about what's happening on board at 14.6 billion miles from Earth. NASA says the interstellar probe works normally and listens to Earth's commands. As usual, the spacecraft is still collecting and sending scientific data, while the mission team tries to figure out where the problem came from. Unfortunately, engineers can't figure out what Voyager is trying to say because its signals don't match any state of the AACS they've seen before. Even though there's a problem, Voyager 1's antenna is still pointed in the right direction when communicating with Earth. Engineers don't pick up on anything unusual in the space broadcasts, even though they may pose a threat. Suzanne Dodd, the Voyager 1 and 2 mission manager at NASA's Jet Propulsion Laboratory, says this is standard procedure in the Voyager mission since it's in a region of the universe about which we know very little. Both satellites are still active, about 45 years after their missions were expected to expire. She said both Voyagers are in interstellar space, a high-radiation environment where no spacecraft has ever gone, to determine if the AACS is the cause of the incorrect data or whether another source is to blame. The NASA team is keeping a close check on the signal. It was possible the team wouldn't figure out what was causing the anomaly and would have to accept it. If they didn't find the issue's root, it may be corrected with a software patch or a hardware rollback. Given that Voyager 1 is now positioned at a distance of 14 billion miles and that it takes roughly 2 days to broadcast a message to the probe and obtain a response, time is of the essence. No one anticipated the Voyager spacecraft would continue operating for so long after its launch in 1977. Only these spaceships can collect data from the void between the stars and make the first ever contact with another civilization. How would you describe the black hole's unique acoustic signature if you could do so? A NASA audio has been called ethereally fantastic and frightening by Twitter users who have heard it. The Perseus galaxy is 240 million light-years from Earth, and there is a black hole with something to say. NASA has extracted and audibled the sound waves discovered there over 2 decades ago. Since many people couldn't fathom that anything, much less a sound as horrific as a guttural moan, could have come from the black hole, the 34-second clip quickly gained widespread attention. The vastness of space described the immense volumes of gas that ring the hundreds or maybe thousands of galaxies within it. Sound waves travel through the air through the molecules. Experts caution that the NASA remix doesn't accurately portray what it could sound like to be close to a black hole. Michael Smith, an astronomy professor at the University of Kent in England, said, "It is perfectly feasible to believe that there are sound waves in the galaxy cluster, and if we were there, we could hear them." Arcand recognized that the Perseus galaxy cluster needed a certain pressure, heat, and gas to create sound waves, or an intelligent civilization we never heard of. Philip Morrison and Giuseppe Cocconi proved in 1959 that space-based observatories could pick up radio transmissions from Earth. This started the search for extraterrestrial life in the scientific community. It was also this year that astronomer Frank Drake positioned a radio telescope at two nearby sun-like stars for the first SETI search, dubbed Project Ozma. With the advent of laser in the 1960s, scientists could prove that it would have been able to detect the light of other planets. At first, it was thought that strong signals coming from outside our solar system would be the best way to find radio or laser transmissions from aliens. Astronomers in the 1960s didn't look for TV and radio signals from Earth that might have reached space in a planned way because the technology wasn't good enough. Finding artificial radio and laser emissions is a frequent SETI method nowadays, but this strategy is based on the idea that advanced alien societies are looking for ways to communicate with Earth. Since humans never send location-specific signals into space, scientists have suggested that extraterrestrial life forms may also opt not to announce their existence. The Search for Extraterrestrial Intelligence project expects transmissions from possible extraterrestrial civilizations. In 1960, scientist Freeman Dyson suggested that an advanced civilization could use a huge solar panel to get a lot of energy from a star, which is the most powerful energy source in any planetary system. With advanced technology, the captured light could be put to good use, as astronomers show infrared radiation from a star system is easily detectable. There's also the option of waiting for a star's brightness to fade as it gets closer to the megastructure. Scientists can grasp the right timing when a star's light is blocked by enormous artificial satellites orbiting it. If this were to occur, the star's luminosity would diminish. Astronomers will be able to figure out how to measure this in the future, just like they have figured out how to measure the effects of other planets. NASA astronomers have studied pollution as a possible indicator of technological quality. In most cases, people are to blame for releasing chemical contaminants into the environment. The James Webb Space Telescope, which looks for signs of life on other planets, can detect these molecules in the atmosphere of exoplanets. Finding things in the atmosphere of an alien planet that can only be made in a lab would be a good sign that astronomers had found a world where people can live. And if a planet has cities and industries emitting artificial light or heat, or it has a large fleet of satellites in orbit, these features could be visible to highly sensitive optical and infrared telescopes. A highly developed civilization would have to produce far more heat, light, and satellites than Earth to be seen in the vastness of space. To what extent does signal quality vary? There's only speculation as to what the first piece of evidence of alien civilizations would be, given that no astronomer is yet to find a convincing technological signature. No one knows what extraterrestrial technology might look like or what signals may be out there, but there have been a lot of debates about what would constitute a good signal from aliens. More than a few researchers have advocated for a broader SETI approach that includes searching for any cosmic anomalies using our existing physics. But what if the model of physics we know of is all wrong? As a result, several strategies exist for finding extraterrestrial cultures. There's still a lot of exciting work in this sector, since no one knows which technique will result in that first historic exchange with an alien. Have you found any more strange signals from space? Tell us in the comments. Be sure to subscribe, and I'll see you next time.